Hi everyone. So in our previous video on sustainable tokenomics, I introduced you to the concept of value accrual and explained the underlying principles that create these relationships between tokens and value. Today we're going to iterate one step further on these ideas and look at the benefits that diversification can bring to these aspects of our tokenomic design. Now, I originally came by this idea in a report published by Spartan Labs. But I've noticed since that it's actually being implemented by a number of projects and designers, which shows that the tokenomic community is having a shared interpretation and response to the vulnerabilities that were demonstrated by the collapse of Axie's play-to-earn model and other similar designs. Now, this report does a really good job of using analysis of failed projects to provide motivations in favor of diversification. So I'm going to restate those key insights and arguments first before we integrate them into a more generalized account that explains the benefits of diversification through the lens of financial theory. If you want a copy to the original report, I provide links to it in the area below this video. The report leads with a question that everyone's asking at the moment and which I've been engaging with over the past few videos. How do we create sustainable tokenomics? The report asks this question in the specific context of the play-to-earn model that was made famous by Axie Infinity. The authors generalized this as an X-to-earn model, where X could be any activity in principle. They begin the report with a description of the Axie Infinity game and a descriptive account of what made it collapse, mentioning more or less the same points that I highlighted in an earlier video. Those key points are that the game rewards could be pulled out for financial value, and this was designed to be regulated by some burn and sink mechanics that were inside of the game economy. But the biggest sinks only worked by promising more rewards to users in the long run. That meant that in a slowed growth environment, this created skyrocketing inflation, which set off an inflationary death spiral that destroyed the value proposition of this token entirely, making it impossible to recover. All of this was compounded by the fact that players were leaving the game because they were never interested in playing the game itself. They wanted to extract value. The authors then move on to a second case study, Stepn, a physical fitness app that shares many similarities with Axie in the sense that some gamified action is rewarded with a blockchain token that can be exchanged for other assets of financial value. So in our X-to-earn, this is now a move to earn. Authors believed that Stepn made meaningful improvements on the Axie model. The designers offered a more imaginative set of actions to burn the reward token as a means of regulating inflationary pressure. This included being able to buy actual physical footwear and buy unique NFTs as well. Importantly, the actions of these sinks were permanent. They did not rely on a value proposition to users of being able to claim more rewards tokens in the future. That's what Axie was doing, and we saw that this setup makes it almost impossible to manage sustainably. Despite Stepn's improvements, though, it still proved to be unsustainable once the broader market turned down after the lunar crash in May of 2022. Stepn's physical asset sinks, the footwear, were priced too high to continue sinking in a depressed digital asset price environment. And then the perceived value of the NFTs was also tightly linked to market conditions, which comprised the sinking function that they offered. It's also worth noting that these characteristics created friction that slowed growth down at the top and then tipped it over into that inflationary spiral. Finally, the authors point out that, once again, people started fleeing the economy because the main utility to them was cashing out the reward token for other assets of financial value. I'm happy with all this analysis, by the way. It all makes perfect sense. We then get on to the final section of the report, which asks, what lessons can we learn from all of this? Or in their words, how can X-to-earn tokenomics improve? They come up with 3 recommendations. The first is to design the economy to use a single token. Second is to avoid relying exclusively on sinks that appreciate in value during high growth conditions. Finally, they suggest that we use mechanics that enable what they call extrinsic value accrual. Let's expand on each of these one at a time. First, the token model. Axie Infinity and its various clones use 2 tokens, the reward token, which served as the value off-ramp, and a governance token. The authors argue that a single token model should be preferred for these applications, arguing that a dual token model makes everything harder to optimize, and that a multi-token model also divides up incentives that may benefit from being aligned. I agree with this recommendation as far as it's presented, but it is fair to recognize that it may not cover all situations. There may be cases where it is highly beneficial for incentives to be separated, or where optimizations for a dual token economy can be handled somewhat independently, for example. It's also worth noting that one of the lesser known motivations behind the dual token model design was to simplify the smart contract code of the rewards token so that users could benefit from lower end-use fees. On the whole, however, we should expect that the impacts of gas economics to become less of a constraint on tokenomic design as network capacity improves and fees decrease. Let's move on to their next recommendation: avoiding creating sinks that become too expensive to access during the boom times. They observe how this happened to be true for both Axie through the cost of its playable NFT characters and for Stepn through the cost of its footwear and NFTs. All these sync assets rose in value as the economies became heated, and that meant that in periods of higher growth, higher valuations would end up choking the sync resilience by locking out newer and less wealthy players. This makes syncing increasingly reliant on a smaller section of players, which ended up putting a brake on growth and increased the risk of tipping everything into an inflationary spiral once again. All of this makes perfect sense. Great insights here too. And then we get to the final recommendation, which is the one I've saved for last, because this is the insight that really made something new click for me and motivated me to make this video. The report authors argue that the main reason that sustainability proved elusive for Axie and Stepn is that the revenue and sinks were too narrow and situated inside the economy itself. This narrowness led to a lack of resilience in lower growth and depressed market conditions. This led to people leaving because their main economic incentives vanished, which is what led inflation to spiral out of control at an even faster rate. Now, in earlier videos that I've released, I've argued that a common problem with unsustainable projects like these is that the value proposition they are making to users is over-financialized to begin with. So one way to do better and get users to stick around is to ground utility on a good or service that isn't dependent or badly affected by speculative or extractive demand. But in this paper, we are limiting ourselves to an examination of the X to earn model. The premise of this application fundamentally is to offer users a financial reward for the performance of some activity. This pitch makes the central utility strongly focused on a financial return, which gives us much less wiggle room to try and make it less susceptible to unsustainable extraction. Okay, so let's take that constraint of promising users a financial return as given. The authors say that there is something we can still do in this situation, and they propose a really clever idea. They propose that we create value accrual for token holders by using claims on goods and services that are external to the token economy itself. This is what they call extrinsic value accrual. So instead of only designing our tokens to claim value within the economy, better design should be able to offer users, and I quote, complementary off-chain rewards like vouchers or discount coupons from major brands, or even tickets to real-world sporting events. This creates a fundamental and inherent value proposition which will be complementary to the game's on-chain token economy rather than reflexive to it. And this is the key phrase here: complementary to the token economy rather than reflexive to it. Now, out of context, it wouldn't be clear what this means, but we do know what it means thanks to the clear examples that they gave us just above with those real-world tickets and so on. This is a great idea and I'm absolutely behind it, but there's a deeper reason why it's a good idea that isn't being expressed explicitly here. And it's a pity because it links in naturally with some financial theory that's really broadly accepted and even won the Nobel Prize. So I would like to restate this recommendation in the following way. We can improve token value resilience with designs that use multiple diversified value accruals. Hopefully the statement offers some intuitive resonance to you already, but what exactly do we mean by diversified here? We can answer that in a clear and specific way by taking a look at ideas that were brought together in modern portfolio theory. Let's go for a quick recap. First, the modern term is anachronistic. It was only modern in 1952 when it was invented. The theory was developed by Harry Markowitz and was awarded the Nobel Prize in Economics in 1990 for this work. It is a mathematical framework, but don't let that worry you, because all that the math is doing is adding some rigor and detail to common sense intuitions that you already have about risk. As the old saying goes, don't put all your eggs in one basket. MPT addresses the question, how do we construct the optimal investment portfolio? Which assets should that portfolio include? MPT's answer is to say that we should choose the selection that minimizes our financial risk. That's the statistical variation in the payoffs returned by the portfolio as a whole. The calculations we use to decide this depend on inter-asset correlations, as we see in the mathematical expression shown. The W's are weights which count the share of the investment committed to each portfolio asset, a strictly positive number lower than 1. The lowercase sigma is the standard deviation of each asset, a strictly positive number. And the lowercase rho is the correlation between those assets, a number that's bound between -1 and +1. So this expression tells you that if you add assets to a portfolio that are not perfectly correlated with it, that have a rho that's less than 1, your portfolio gains a diversification benefit. Let's go through a quick demonstration of how that works. Imagine we're comparing two possible additions to our portfolio. In the first case, we're adding a mini copy of the existing portfolio, and because it's a mini copy, its payoffs move in exactly the same way as the original portfolio, so it has a perfect correlation of 1, okay? In the second case, all the attributes are exactly the same, except for the fact that the new asset has a correlation that's lower than 1, okay? Comparing these two expressions with each other, we know they are exactly the same, except for the last item, which contains the correlation term. Let's compare this last term, which differs between option A and option B. Now, since all the weight and standard deviation terms are strictly positive and the same, we're left with the conclusion that option A is larger than option B just because its correlation is larger. And from there, it follows that the variance of the combined portfolio is larger for option A than it is for option B. And because of the way we set this example up, we know that this is exclusively attributable to the diversifying effect of the lower correlation measure that we have in case B. Now, it's true that we kept all the other values the same in order to help make this explanation clear, but allowing them to change doesn't actually affect this result. If we allow them to change, the overall variance of the new combined portfolio may end up being higher, but that doesn't negate the fact that by having a correlation term that is lower than 1, the final portfolio variance that we get is lower than it otherwise would be if we had added an asset that was perfectly correlated. It is in this sense that we always get a diversification benefit by adding new assets that have a correlation measure lower than 1 to an existing portfolio. Okay, but what does portfolio construction have to do with tokenomics? Well, an investment portfolio offers a risky or uncertain claim on value. And to the extent that we design our tokens to hold value, they are intended to do the same thing. In both cases, stakeholders are risk averse and prefer lower variance portfolios, so we want to minimize risk in both cases. Now, in the portfolio case, the asset manager is picking securities, which offer a legal claim on cash flows from some business process or ownership to an underlying commodity or derivative financial contracts thereof. The asset manager does not have any control over those contracts, claims, or business processes. But as tokenomics designers and engineers, we do. Sure, the outcomes of our economic processes are jointly determined by agents whose actions we can't control. But the premise of tokenomics is that the rules that we design and create will result in somewhat predictable consequences on these agents' behavior and on the value, price, supply, and distribution of resources within a token economy. So that means that we can apply portfolio optimizing considerations into our token design work and attempt to build value accrual mechanics in line with the goals of modern portfolio theory to minimize financial risk by maximizing the risk diversification that these mechanics provide. Okay, time to put our feet on the ground again. How do we integrate these insights practically into our value accrual designs? Well, remember from the earlier video that value accrual generally consists of two parts: features that define tokens' claims to value, what I term their claim rights, and actions that change the quantity of tokens, monetary actions. Let's start with the claims rights first. If you remember, an important distinction that we highlighted concerned the origin of value, as to whether it was endogenous or exogenous, meaning whether the value had been created inside the blockchain economy or outside of it. It will also be informative for us to pay attention to the constitution of the asset. For today, it's enough for us to distinguish between digital assets stored on public blockchains, digital assets that aren't on public blockchains, and physical assets. I argued that claims on endogenous blockchain secured value are likely to be the most valuable and compelling that project can make, especially if the endogenous process that generates these assets benefits from economic efficiencies that non-blockchain alternatives do not have. So let's assume that we've successfully designed such a process and have created some value accrual mechanics that instate a value relation between the token and this kind of asset. So taking our lead from modern portfolio theory, what other value claims could we add to our tokens to diversify our risk? Let's consider our options by examining assets with different combinations of these key attributes that we've just been highlighting. First, consider what would happen if the claims were to other blockchain assets that were sourced through the same endogenous economic process, say NFTs that are linked to internal economic activity that can be purchased at some advantage by token holders. This format lines up with Axie's playable NFT characters and Stepn's NFTs. If these assets are generated by the same economic process and derive their value from claims inside of the economy, it is very likely that they are going to be very highly correlated with this original internal value claim or utility. It's true that the correlation would unlikely be a perfect one, but the diversification benefit of just adding one or two such extra value claims would be negligibly small. A much greater number of such assets would need to be added to even make a minor difference to overall risk. Circling back to observations made in the report, this was the core failure highlighted for Axie and Stepn's designs, that their token utilities or value claims were just too narrow and narrowly situated inside the game economy itself. This meant that they were subject to the same risks as each other and failed to offer value support and resilience in the event of a downturn. Now let's consider a minor change to this setup. What would happen if our blockchain assets were still endogenously sourced, but from a separate endogenous economic process, a second game, for example? Well, in this case, the diversification offered may be a little bit better than before, but it's hard to imagine how contagion from the collapse of one economic area would not simply just spill over into the other if the two economies are linked by shared economic assets. This variation, therefore, is unlikely to offer material improvements over the last one. Okay, so let's try something that's more obviously different. How about giving token holders a claim on an off-chain physical asset? Well, it sounds like a good diversification play, right? Instead of giving users claims to other blockchain assets, we're now giving them claim to something that's entirely different. It's physical. Seems reasonable. But the differences in asset constitution are not a sure guide to creating substantive diversification of risk. That's made clear by the example of Stepn's physical footwear. In this case, the physical asset's value was heavily correlated with internal economic factors, and that ended up mattering far more to its correlation profile than the difference in its constitution. And we see that the report authors understand this insight and carry it to its logical conclusion. They argue in favor of creating value claims that are not just physically constituted, but that rest on a value proposition that is entirely independent or uncorrelated with the project economy. And the value of you going to see your favorite sports team play is just that. And it doesn't depend on how many other players are active in the extra-earn economy or what the price of Bitcoin is doing this week. Now, it's worth noting that the difference in asset constitution, these being live physical events, is not just incidental to the diversification benefits that they offer, but we need to be clear that it isn't the primary factor. To help expound on this further, we could create similar diversification benefits using off-chain digital assets that offer benefits in some other uncorrelated digital economy or experience, like special access, buffs, power-ups in a popular video game. This will work as long as the value of that game is less likely to vary in sync with the state of the project economy that we're trying to diversify from. Again, this helps make clear that asset constitution is not the determining factor when evaluating risk diversification. But even with these solutions, there's still fine print that's worth paying attention to, because if we're not careful, these claims to uncorrelated exogenous value may still end up being correlated with internal economic factors. Think it through. If these value claims are exogenous, they have to be procured by way of some free economic agreement that's made with external parties. We need to ask, how is that going to be funded? And one of the purchases could be made in advance, but they are unlikely to be unlimited in that case. Or perhaps they're funded by endogenously generated revenues, which means that if those revenues are highly correlated with internal economic factors, the ability to secure diversifying value claims will be at risk. Or perhaps you're thinking you could improve matters by funding the commitment out of endogenous reserves that you set aside for a rainy day. But even in this approach, the success is contingent on there being enough funds in those reserves and those reserves to be comprised of assets that are uncorrelated with internal economic factors that we're trying to diversify away from. Okay, one more, just to make sure that we've covered all our bases here. Let's also discuss the diversification benefits of adding claims to other exogenously sourced blockchain assets. These are likely to offer very poor diversification since, with the exception of stablecoins, crypto assets are incredibly highly correlated with each other as an asset class, something lots of us feel incredibly frustrated by, I can assure you. But in the future, if we ever do see greater decoupling between these correlations, these claims could add some diversification benefit. Okay, last thing to wrap up with here. As you may have noticed, we didn't cite any correlation measures to advance our arguments convincingly, but we do have the option to reach out for this mathematical tool if we're exploring options that are less clear-cut, or of course, if there's already a live operational project generating data, which then allows us to measure correlations to monitor the diversification performance of our mechanics much more rigorously. Okay, so that covers how we can apply risk diversification principles to the design of our claim rights. Now, how would diversification aims shape the design of our monetary mechanics? When it comes to the mechanics that expand supply, generally speaking, it's going to be less challenging to design them in ways which are responsive and resilient to different conditions, since on the whole, they sit in centralized control, and these arrangements are seen as ethically acceptable by project economic communities. It's the sync design that poses the greatest challenge since, generally speaking, the only ethically acceptable syncing actions are those that are taken freely by the token holders themselves. Anything else would feel like theft or destruction of property from the token holder's perspective. And that's why value claims are naturally usable as syncs, because they provide users with an exchange proposition that allows them to freely and fairly relinquish control of assets that they've acquired at some earlier economic cost. And so when claiming and syncing are linked in this way, the work we've done to diversify our value claims already diversifies our syncing to some extent. But if they are linked this way, it also means, and we need to bring that awareness of this syncing function to bear on the choices we make for designing our value claims in the first place. If we're choosing exogenous value claims in order to sustain syncing under depressed economic conditions, we better make users an offer that's likely to be chosen by a large share of our token holders in order for our sync to continue performing effectively in a downturn. Part of this analysis could involve examining how consumption behaviors change under different valuation scenarios. Would substitution into consumption of the uncorrelated asset offer enough syncing action to support the unit value of the token base? All of this also leads us to the recommendation that we need to avoid concentrating sync functionality in the actions of a specific user demographic, as much as we need to avoid it being dependent on specific economic conditions. And ladies and gentlemen, that's it. Quite a technical lecture, I know, but really, core insights can be explained quite intuitively. Don't put your eggs all in one basket. Make your token valuable and useful in ways that aren't totally subject to the conditions of your blockchain economy. Design a diversity of sync mechanics and make sure that they avoid narrowly concentrating that function on a narrow part of your demand base or a narrow set of economic conditions.